Okay, question 4c. We are now asked to estimate the standard deviation for the daily total rainfall. First of all, to get full marks for the question, you want to make sure that we write down the formula. So just to remind you, the variance, sigma squared, is the mean of the squares minus the square of the mean. So the standard deviation is the square root of that. Sigma is the square root of mean of the squares minus square of the mean. My formula then, my mean of the squares is the sum of fx squared divided by sigma f minus sigma fx over sigma f. There's my mean, all squared. Looking at what values I need, I'm given sigma fx squared. I'm given sigma fx. From before, from last part of the question, I calculated sigma f is 184. Plug those into this formula. Do write on your exam paper that formula with the numbers plugged in full. Now, just as a tip, you then put that straight in your calculator. Please do write the full or a lot of the digits on your calculator. Don't go straight to rounding it. It's a good technique just to make sure you're picking up more marks. So that's what I get for sigma, and then I've rounded it here to 2 decimal places. So part D, one assumption involved when you're using midpoints is that the data is spread evenly across each class. So whereas when we went 7/24ths into this class and we assumed that the 24 bits of data here were evenly spread across this range, that's our basic assumption. Why this assumption does not hold in this case, if you look that these 121 values are all down very low here in the 0 up to 0.5 range, that would include a lot of values that are at 0 or trace values. So we might even say the majority, probably the majority of values in the first class would be at or close to 0. We then have to say then whether our estimate would be larger or smaller than the actual mean. Well, in our estimate, we've assumed that all 121 of these values are at the midpoint, 0.25. And normally it's a fair assumption if they're linearly distributed across the class, because the ones that are below that would balance out the ones that are above it, and it's normally a fair assumption to just assume they're all at the midpoint. In this particular class, many of these values will be at 0. They won't necessarily be balanced out by anything above that midpoint. So we've assumed a lot of these are higher than they are. Therefore, we've got an overestimate and the actual mean would be smaller.